Hello, space enthusiast. Welcome to my YouTube channel. Today, we are going to take a fascinating journey through history and explore five failed missions of Moon that have left an indelible mark on the space explorations. Join me as we uncover the challenges, setbacks, and the missed opportunities that paved the way for future lunar successes. So, let's get started. First mission is Lunar Prospector. Lunar Prospector was the third mission selected by NASA for full development and construction as a part of Discovery program. At a cost of $62.8 million, the 19-month mission was designed for low polar orbit investigation of the moon, including mapping of surface compositions, including lunar hydrogen deposits, measurements of magnetic and gravity fields, and study of lunar outgassing events. The mission ended on July 31st, 1999, when the orbiter was deliberately crashed into the crater near the lunar south pole after the presence of hydrogen was successfully detected. Data from the mission allowed the constructions of a detailed map of the surface composition of the moon and helped to improve the understanding of the origin, evolutions, current state, and the resources of the moon. Several articles on the scientific results were published in the journal Science. Lunar Prospector was managed by NASA Ames Research Center with the prime contractor Lockheed Martin. The principal investigator of the mission was Alan Binder. His personal account of the mission, Lunar Prospector, against all odds, is highly critical of the bureaucracy of the NASA's overall and its contractor. In 2013, an unidentified object was discovered in an unstable orbit around the Earth and assigned the provisional number WT1190F. After it crashed into the Indian Oceans, it was identified as probably the translunar injector of Lunar Prospector. Next on our list is infamous Apollo 13 mission. On April 11, 1970, the powerful Saturn V rocket carrying the Apollo 13 mission launched from Kennedy Space Center, propelling astronauts Jim Lovell, Fred Hayes, and Jack Swigert on what was intended to be the humanity's third lunar landing. Unfortunately, the mission to explore the Framao region of the moon did not go as planned. What many viewed as a now routine mission soon had millions around the globe glued to the television set, watching and hoping for a positive outcome for one of the most intense episodes in the history of space explorations. The overwhelming success of the Apollo 11 mission in July 1969 and the subsequent Apollo 12 missions gave many the impression that the lunar landing was almost a routine in nature. Combined with the clashes over the Vietnam War, the public attention increasingly turned away from the Apollo mission. Shrinking budgets threatened much of the Apollo missions, leading eventually to the cancellations of Apollo 18, 19, and 20. Those of the superstitious persuasions noted that even the upcoming Apollo launch suffered from all the unlucky lore surrounding the number 13. Some validity of those fears proved warranted when the measless scare prompted the replacement of the command module pilot Ken Mattingly with the Jack Swigert. The mission got off to an auspicious start when, during the launch, the Saturn V experienced an early shutdown of one of the second stage J2 engine, burning the remaining 4 engine an additional 34 seconds longer, and the third stage an additional 9 seconds placed Apollo 13 in the proper orbit. Afterwards, the mission settled into what increasingly felt like a routine journey, prompting Joe Carvin, a capsule commander back in Houston, to proclaim that the spacecraft is in good shape and that he and everyone else in the control room were bored to tear down here. Minutes later, the explosions of oxygen tank number 2 exploded. Those ended the feeling of boredom entirely. As a warning light in the cabin indicated the loss of two of the three fuel cells, the crew communicated to the Houston that indeed they had a big problem. Looking to the outside of the command module, Odyssey's Lowell noticed they were venting something out into the space. The venting was, in fact, the lifeblood of the mission oxygen. The crew discovered that the explosion in the tank number 2 had also damaged the tank number 1, a problem which made use of the fuel cells impossible, threatening the eventual loss of all the electrical power and water. With the lunar landing now erased from the equations, both the astronauts aboard Apollo 13 and the NASA personnel on the ground worked tirelessly around the clock to develop the solutions that would allow them to return home safely. The immediate response plan was to enter what was known as lifeboat mode. Here, the lunar model Aquarius become central to effort the save the beleaguered spacecraft and crew. Aquarius' full oxygen tank and descendant engine both proved critical in keeping the crew alive and returning them to the Earth. Along with the extreme shortage of water and electrical power, the crew also encountered dangerous level of carbon dioxide. Plenty of lithium hydrogen canisters designed to remove the gas from the spacecraft were on hand in the command module. The problem, however, was those square canisters were not compatible with the round opening in the Aquarius. Doing what engineers do, support staff in Houston devised a method for fitting a square peg in a round hole. After taking a free return to Earth trajectory and using the Sun as an alignment star for navigation, Apollo 13 soon found themselves approaching home. One final problem remained powering up the command module after its seemingly long hiatus from the actions. Under the normal conditions, the process of writing new procedures would take 3 months. Houston has 3 days. One major issue concerns whether the cold condensations of the instruments would start or short circuit when power returned. Year later, Hess remembered the command module looking as though someone had sprayed with the hose, and that the crew had to wipe everything off with the towel. Fortunately, activation caused no arcing. Why not? The answer could be found in the lessons learned from devastating Apollo 1 fire in January 1967, after which the major redesign was undertaken to add increased insulations for better protecting of the wiring. On April 17, the crew said goodbye to Aquarius and returned to the Earth, splashing down in the Pacific Ocean near Samoa. Only when the crew was safely aboard the recovery ship USS Iwo Jima would everyone at NASA and around the world finally begin to excel. The lessons learned from the successful failure Apollo 13 were rapidly applied to the remaining Apollo missions and continue to guide safely and mission assurance at NASA today. Next in the list is Beresheet, which was Israel's first lunar missions and the first attempt by a private company to land on the moon. The mission achieved lunar orbit but was lost during the April 2019 landing attempt. NASA had installed a small laser retroreflector aboard the lander to test its potential as a navigation tool. Beresheet means in the beginning in Hebrew. Beresheet was about 5 feet tall by 7.5 feet wide and its landing gear and legs deployed. The lander separated first from the rocket, taking the long route to the moon to save the fuel by employing gravitational force to propel itself. Beresheet slowly widened an elliptical orbit around the Earth until it was captured by the moon's gravity and ultimately commanded to descend. Beresheet attempted to touch down on April 11, 2019 in an ancient volcanic field known as Sea of Serenity. NASA's Apollo 17 astronaut landed near this region on December 11, 1972. The team lost contact with the spacecraft shortly before expected touchdown. While NASA regrets the end of the SpaceL mission about the successful lunar landing on the Beresheet lander, we congratulate SpaceIL, the Israel aerospace industries, and the state of Israel on an incredible accomplishment of sending the first privately funded mission into the lunar orbit. NASA Administrator Jim Bridenstine said on April 11, every attempt to reach new milestones holds opportunities for us to learn, adjust, and progress. I have no doubt that Israel and SpaceIL will continue to explore, and I look forward to celebrating their future achievements. Our next failed moon mission takes us to NASA's Constellation program, an ambitious initiative aimed at returning humans to the moon and establishing a lunar outpost. Constellation program cancelled US crew space flight program that was scheduled as a successor to the Space Shuttle program. Its earlier flights were planned to carry astronauts to the International Space Stations beginning in 2015. However, missions to the moon by 2020 and to the Mars after that were the main focus of the Constellation. In January 2004, US President George Bush called upon the NASA to resume crewed mission to the moon and then bring crewed missions to the Mars. A key requirement was that this new program be funded by retiring the Space Shuttle in 2010 after completing the ISS. The new program, called Constellation after the US Navy's first ship, would have comprised launch vehicle, a crewed spacecraft, and a lunar lander. A number of options were considered for the new launcher, including adaptations of the existing Delta IV and Atlas V rockets. Before it was decided to exploit the space shuttle technology to create two new launch vehicles, in June 2006, NASA named the new launcher areas after the Greek counterpart of Roman Mars god. Ares 1 was designed to carry the crewed spacecraft, and the larger Ares 5 was designed to carry the heavier cargo like the lunar lander. In August 2006, the crewed spacecraft, initially dubbed the Crew Exploration Vehicle, was named Orion after the constellation. Orion would have been 5 meters in diameter and would have a launch mass of 22,700 kg. It would have consisted of a conical crew module and a cylindrical service module and would have been able to spend 6 months docked to the ISS. The crew model would have had a volume of 20 cubic meters, half of its habitable. It was designed to carry a crew of 4. The service module would have housed the main propulsion system, the attitude control system, and the oxygen and water for the crew module. The overall configuration was reminiscent of the Apollo spacecraft, but the service module would have drawn power from deployable solar panel rather than the fuel cells. A prototype Orion was delivered to NASA in late 2007. The first and the only test flight of the Ares 1 launched in October 28, 2009, and the first launch was the crew was initially scheduled to be directed to the ISS in 2015. In December 2007, NASA named the lunar lander Altair after the brightest star in the constellation Aquila. Aquila is the Latin word for eagle, which was also the name of the first crewed spacecraft to land on the moon, Apollo 11. Lunar module Altair would have been a two-stage spacecraft, a descent stage and an ascent stage, and would have landed 4 astronauts on the moon. Its launch mass would have been 37,800 kg. For a crewed mission to the moon, an Ares 5 would have launched first, carrying Altair into the Earth orbit. and Ares 1 would have been launched with Orion, which would have docked with Altair ascent stage. The second stage of Ares 5 would have reignited to send Altair and Orion to the moon, after which the docked spacecraft would have withdrawn from the spent age. The service module main engine would have slowed Altair and Orion so that they could enter the lunar orbit. The crew of four have transferred to Altair and landed on the moon. On the early mission of the surface expeditions would have lasted a week. The descent stage of Altair would have served as a launch platform for the ascent stage used in lunar orbit and Orion. The crew would have been transferred to Orion, after which the ascent stage would have been jettisoned. The service module's main engine would have been able to leave lunar orbit. Just before the spacecraft re-entered the Earth's atmosphere, the service module would have been jettisoned. The capsule would have been then discarded its basal heat shield and deployed its three parachutes. The normal mode of return would have been on land in the United States, but if necessary, the capsule would have splashed down at the sea. In May 2009, the administration of President Barack Obama announced that it would review the Constellation program to determine whether it would be the best option for US crewed spaceflight after the end of Space Shuttle program. In October 2009, the review committee announced that barring a significant increase in NASA's budget, the schedule of Constellation program was unrealistic, with the first crewed flight, Ares 1 flight, likely occurring between 2017 and 2019. In February 2010, the Obama administration cancelled the Constellation program in favor of commercial flights to the ISS and research on lowering the cost of crewed space. However, in April 2010, Obama announced that work would proceed on the Orion capsule, but as a vehicle designed solely for astronauts to escape the ISS in an emergency. Orion was incorporated in 2013 into the asteroid redirect mission, in which the early 2020s probe would retrieve a boulder from an asteroid surface and bring it to lunar orbit, where astronauts on board an Orion spacecraft could study it. Orion had its first flight test on December 5, 2014, in which the capsule landed by a Delta IV heavy rocket made two orbits. The asteroids redirect mission was cancelled in 2017. Orion development nevertheless continued, and that same year Orion became the part of Artemis, the crewed lunar exploration program proposed by Donald Trump administration. The next one in the list is Chandrayan 2. India's Chandrayan 2 took off from Sriharikota on July 22 to safe land the Vikram, carrying its Pragyan rover in a suitable high plane on the lunar surface at altitude of about 70 degrees south, but soon after 1:50 am on September 7, in the final minutes of lander descent on its own, the ISRO lost contact with the module. So, what went wrong with this mission? Chandrayaan 2, comprising an orbiter, a lander, and a rover, journeyed from Earth to 8 days and reached the moon vicinity on August 20. On September 2, the lander riding on the orbiter was separated and got closer orbit around the moon, moving a pole to pole at a distance of about 35 km by 100 km. Mission planner at ISRO had divided the last critical 15 minutes parabolic descent into a smaller phases. At 1:38 am Indian Standard Time on September 7, the lander perfectly cleared the rough braking phase, swooping down from 30 kilometers to 7.4 kilometers to the lunar surface in 10 minutes. Its velocity had dropped as required from 1640 meters per second to a 400 meters a second. It had now entered the second part, the fine braking phase of 3 minutes, with the 4 throttleable motor switching off to further lower the velocity. It had to reorient itself, take a picture of the landing site to look to the hazardous like slopes and rocks. The moon was just over 2 minutes and 2.1 km away. But by then, at the command headquarters in Bangalore, the green lights on the screen showed that it had strayed from its path. The mission manager said that they were not receiving any signals from the lander. Vikram had developed a problem, gone silent, and had crashed at the fag end of the perfect journey. Along with the stillborn rover, some 20 minutes later, ISRO chairman K. Sivan announced that the contact has been lost with Vikram and ISRO was piecing together its last set of data. While the failure analysis committee reconstruct and simulate the last moment to infer the causes, theories abound about what may have caused the crash. Did the thruster overperform? Did Vikram lose attitude and not recover, losing the earthling, or what it may some anomaly? However, since then, ISRO has spoken only once in the last 7 days just to say it had located the crashed Vikram and would try to reconnect it. It must do so before lunar night sets in around September 21st, cutting off any solar power supply to the spacecraft. Why was this mission so important? For ISRO, this was the second moon mission after Chandrayan 1 of 2008. The project, approved in 2007 and planned for 2012, had undergone a few twists, turns, delays, and redesigns over the last few years. Finally, in June, Dr. Sivan formally announced that it would be launched in the mid-July. Chandrayaan 1 was orbiting mission and died just 8 months but not confirming before confirming the existing presence of water molecules on the lunar surface. Chandrayaan 2 planned to take off from where its precursor left and look intensively for water deposits from up close. It was formidable combinations of an orbiter, a lander, and a robotic rover, which aimed to look at the moon's exterior surface and interior in that order. So, what were the challenges? Dr. Sivan had repeatedly spoken of the challenges of soft landing on moon. The spacecraft had to land unharmed and intact, remains in touch with Earth, and do its assigned job. Of nearly 80 missions sent on moon since the early 1960s, less than 40% have succeeded. This year alone, China's Chang'e mission made the first ever landing on the far side of the moon in January and also deployed a rover. But in April, Israel's Beresheet crashed on the moon. The lunar terrain is rocky and uneven. The moon's gravity is about 17% of the Earth, and just dust that slowly rise and fall off landing can disable sensitive instruments of the lander. Many technologies of Vikram are new. The lander and its leg, the autonomous rover, and four throttle motors happened after this. In the end, India did not arrive on the moon. The country had the aim of becoming the fourth member of the Lunar Club after the Soviet Union, the US, and the China. And for Chandrayaan 2, we may have heard the last of the lander and the rover. But the orbiter gliding 100 kilometers above continued to bear the Chandrayaan 2 torch, beaming back pictures of the moon. The informations it will send as it revisits the spots where Vikram lies may offer precious lessons for future planetary missions by India and other countries. Although it fell short of its goal, the mission still accomplished significant achievements, including the successful orbiter insertion. As we conclude our explorations of these failed moon missions, it's crucial to recognize that setbacks and failure are an integral part of scientific progress. Each of these missions contributed to our understanding of the moon and provided valuable lessons for future endeavor.